or you can consider it as a say or you can consider it as a drain current, and this as a Ix. So ID plus Ix equals to 0. So this is ID, and so AVX GM plus Ix equals to 0. So Vx upon Ix 1 by GM A. Now let's consider another configuration. Okay, so here in negative feedback or anything in negative feedback with gain A, it is going to make output resistance as a 1 by GM by A. Now let's consider another circuit. So this is something like this, something like this. So this is C1, this is CC, and here we need to find out output resistance. So this is, say, we will put Vx, and we will make, say, this is some beta factor of Vx will come appear here, Vx. Now here this is Ix, this is, say, ID, this is beta Vx. So ID equals to minus beta Vx into GM of device. Ix plus ID equals to 0, Ix minus beta Vx, GM equals to 0, Vx upon Ix equals to 1 by beta Vx, where beta we can find out as a Cc upon C1 plus Cc. So this is beta factor ratio of these two capacitors, and so this is you can say some gain beta in feedback path. So all these are similar kind of examples or circuit, but way of representation is bit different. Okay, so now let's consider one more example of similar way. Say this is basically negative feedback kind of circuit. Say there is a gain A, and this is amplifier with output resistance, say, RO, and there is a beta feedback factor, and this is plus, this is minus. So this is negative feedback. We need to find out R out. So we will again apply one test voltage, say Vx, and here current Ix will go. Here Vx is appeared, so here beta Vx 0 minus beta Vx, so here minus beta Vx will appear, multiply by gain. So this voltage is minus A beta Vx, and this is Vx. So say this is IO plus Ix equals to 0. IO is minus A beta Vx minus Vx divided by RO plus Ix equals to 0. So Vx upon Ix will come as a RO 1 plus A beta. So this is output resistance. Now Lg is loop gain, which is given as equals to A beta. So for negative feedback, output impedance of amplifier is basically reduced by loop gain. So this is negative feedback configuration. So this is one of the advantage of negative feedback configuration. Now let's consider uh, one more circuit which is known as flip voltage follower. Flip voltage follower. So this configuration is known as flip voltage follower kind of. Advantage of this is basically output resistance is reduced and output pole moves to higher frequency. Let's see how. We need to find out R out. So here we can observe that this is common gate configuration, and say this is infinite resistance, then for this common gate configuration gain is GMRO. So this will reduce to something gain A. This is CG stage and A equals to GMRO, say. So this will be reduced to something like this. So now we can observe here we need to find out R out. So there is a gain in this feedback path, so R out equals to 1 by GMA. So this is M1, so you can say GM1, this is M2, this is M1, this is GM2, RO2. So this will be GM1 into A. So now output resistance reduced by gain factor of A. So it will actually move output pole to higher frequency. Sorry. Okay. So now just comparison purpose, we are going to see two configurations again. One configuration is this is RS, here we are finding out R out. Other configuration is, say this is some RL, and this is, we are going to find out R out here. So in this, say this transistor gain is A, this transistor gain is A. So in this R out is A into RS GMRO into RS, R out. For this configuration, R out is given by RO plus RL divided by A. RO plus RL GMRO, R out. Now suppose two cases. Case 1, RO much greater than RL, then R out will reduce to 1 by GM. Case 2, RO less than RL, then R out reduced to RL divided by A, RL divided by GM RO. Okay, so if we consider this case, if RL is very small as compared to RO, then if we are applying Vx here, and this is ID, this is Ix, and this is ground, so ID plus Ix equals to 0. ID is GM VGS plus, you can say, Ix